Hello, everybody, and welcome to yet another episode of the Beyond Grad Show. Today, I have my friend Joshua Joseph with us today, and we did not plan the white polo uniform that you are seeing the both of us wearing. It's just something impromptu that we came up with. This is going to be a great episode. We are doing it live because I want people to have access to ask us questions during the interview. If you ask a question, just comment in LinkedIn or YouTube, wherever you're joining us from. If it directly applies to what we are talking, I'll bring it right away. If not, in the end, I will make sure Joshua answers all of the questions that you have. Joshua, it is great to have you here and talk about physical AI. Before we dive deep, love for you to give an about yourself.
Sure. Thank you so much, Varun. I am so honored to be on your show finally. I've been watching all the episodes, like all the amazing content creators and people you've been hosting, and I really love them. And I'm really happy to be here. But again, my name is Joshua Joseph. Feel free to call me Josh. I am from Chennai, India. I came to the US in 2021 for my master's in mechanical engineering. I went to Northeastern University in Boston, great school. So I loved it. And then I moved to Austin to work at Tesla as an intern. I started as an intern at Tesla. I worked as a technical program manager. And then I converted that internship into a full time job and I started working as a process engineer. And then I kept doing that, and then after a few I think after a year I moved to a new project, and I've been doing mobile robotics since then, which is amazing, which actually gave me an insight into physical AI, which I've been recently for the last 1.5 years I've been reading and learning a lot about. And yeah, along through this journey I've been very active on LinkedIn. I've been guiding students and helping early career professionals to get a job, get an internship, and kind of like motivate them on their immigrant journey. So that's what I've been doing on LinkedIn. And yeah, currently I live in Austin, and apart from that, I think I also play the guitar after everything outside LinkedIn. So that's kind of like my hobbies. And yeah, I'm pretty excited to be here and talk more.
Awesome. It's glad to have you here. The first thing I want to start with, by the way, we've already got a comment here. Somebody being super excited about learning more about Tesla and AI. I think that is awesome. What I want to make sure that ask you the first question right away is, what is physical AI?
Great question. That was the same question I started when I started learning about physical AI. But before that, a little bit of background. Let's talk. I think a lot of people know AI, and that's how I thought when I started learning AI. That's when ChatGPT and everything started. So I was like, oh, maybe it's ChatGPT. What ChatGPT can do. But AI is basically, leave physical out of it. AI is basically um, the machine, any machine which analyzes patterns and data and then makes decision on its own. So anything which makes decision on its own is AI, is artificial intelligence. So right now we are entering the agentic AI phase, which a lot of people have heard the term. And then we have definitely peaked at the generative AI phase, which is ChatGPT, Claude, and Gemini, creating images and videos and stuff. But from agentic AI, we're gonna go into the physical AI space, which is basically this AI capability of analyzing patterns in data and making decisions will get into atoms, like anything which is physical. Right now, it's all inside the screen. Like I can open my laptop, and that's where ChatGPT and everything lives. And agents also live, like Microsoft agents and stuff. But moving forward, all this entire capability will go inside an atom or like any matter, and then like robots, and predominantly robots in the future, but also to vehicles and whatnot. Anything which is physical, which we can touch and sense, that is basically how AI is gonna get into. And that phase is gonna be physical AI, to be precise.
Wow. So all of us core engineers, right? Be it mechanical, electrical, civil engineers, we all know about actuators and controllers. Like we all know about that, right? Physical actuators, and then you do some type of coding to make sure that you have a control strategy. How is physical AI different than like having a controller uh, within your component or within your vehicle?
Yeah, that's kind of like the difference. Like that's the difference between automation and AI. Automation, we program it, we code it, saying go from here, go there, stop there, do something else, come back. But in AI, we just feed the data of this entire space, and then it sees us, it sees something going from point A to point B constantly, and then it analyzes, oh, that's the way I need to go. So
Hmm.
that's the difference between automation and AI. That's why automation is tagging along AI, because it's easy. They already have that capability. They're just going to add the AI components to it and make it much more efficient. And so that's kind of like how engineers can basically start pivoting, because they already have some. There are 5 layers, we'll talk more about it, but there's 5 layers of physical AI. And right now it's always software engineers, computer engineers who are like, oh, they become AI engineers, right? Because they are interacting with one of the layers. But there is few more layers which many people do not realize. Even I did not realize until like last year, where even mechanical engineers, manufacturing engineers, electrical controls engineers have an opportunity to be a part of this revolution. Because I guess we completely missed out, right? Like core engineers, like it's always the tech guys winning. So we have a chance to be a part of tech actually.
That is so cool. I think if I knew what I know now, and if I could go back to 2005 when I was deciding between mechanical engineering and computer engineering, I think I would choose differently. I was so passionate about mechanical engineering, so passionate about automotive, so was naturally very drawn to it. At the same time, I mean the entire landscape is so different, and it was just like one choice. I'm sure there were parts in my life where I could have changed, but that one choice had a lot of kind of cascading effects down the line. But you say something very interesting is that core engineers now can now take part of tech, which is so exciting. And then you talked about five layers to this physical AI. Talk to us about those 5 layers. That's very interesting.
Yeah, definitely. It's I learned it from by reading and taking courses about physical AI. I'll also touch base upon some of the important courses which everyone can start. So let's talk about the layers of physical AI. So there are 5 layers, and all five is just like a stack, and then the stack makes physical AI. So the first part of the stack can be simulation layer, where basically industrial engineers do it. They create like digital twins and simulations about factories and smart cities and stuff. So that is one of the layers. So that is definitely needed for physical AI to before you launch like a million humanoid robots into the market, you want to see how it behaves inside a house, inside a factory and stuff. So simulation layer is the first layer. And then the second layer is action layer. Action layer in the sense like motors, actuators, wheels, and end effectors. This is where mechanical engineers come into play picture. So as a mechanical engineer, you're already working with motors, you're already working with wheels, you're already working with design. So one of the layers is action layer. So you're already inside physical AI. You just don't realize. And then the third layer is perception layer. That is, to me, is one of the major layers, because the model will not learn until it sees something, or it you have something for it to like realize and understand. So perception layer comes in the form of cameras mostly. If you look at how a Tesla drives, and it's camera data, like camera feeds. But there's also lidars and tactical sensors and IMUs. So all these kind of like anything which can be seen or felt is perception layer. And then comes the brain, which is the decision layer. That's what is happening currently. That's where all the tech people get involved. Like they build these large language models, they use machine learning, reinforcement learning, and then they build these foundation models and start making the decisions. And then I think the fifth layer is kind of like the purpose layer. Like that is kind of like I think product managers will play a huge role in that. Someone who really understands physical AI, all these 5 layers, they will become product managers. And Basically, purpose layer is kind of like they know what is the end product. For example, I would say Tesla, a car, right? A car is the final purpose, to self-driving car. And then humanoids, working inside the house, like putting, turning on the dishwasher, taking laundry. That's kind of like the purpose layer. It can also be like the robot or whatever that layer component is basically inside a factory, like doing welding or like manual labor. That's the purpose. So it's kind of like a systems integration at that point. Like all these five layers stack up, and then the purpose layer is what finally goes out and then becomes a product. So five
Mm.
layers. Product managers are there, electrical engineers, controls engineers, mechanical engineers are already there, including software engineers. So we're all prepping for physical AI at this point.
Very cool. By the way, we had thunderstorms the last 2 days. So if you see me connecting,
I see
disconnecting, just go with the flow.
that.
And I don't know why. It's this time of the day also sometimes is a problem. By the way, we've got an excellent question about the simulation layer versus the actual on the floor. And I'll definitely take that question at the right moment. What I'm curious to know from you about is, let's take core engineers, let's take mechanical engineers, and let's take electrical engineers. If they want to pivot, which of these layers do you think are the easiest to pivot, or relatively strong overlapped to pivot?
Yeah. Um, Terrific question. That's kind of like the same question I had when I understood like a year back about these layers. Okay, how can I, pivot? So it could be really blunt, but you don't have to pivot. That is the honest truth. Like you already are in one of the layers. Instead of pivoting from action layer, and a lot of people, right? When I studied mechanical engineering, in my masters, when I did masters, a lot of mechanical engineering undergraduate students who came to the US, they moved to data and became data engineers and data scientists because that's a pivot they did, because at that time only AI and decision layer was there. So right now, if someone's telling asking me, oh, should I pivot to data or AI, I would say no, 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 wait. All you need to do is get familiar with the next layer, the next closest layer. For example, if you're in the action layer or perception layer, okay, let's take perception layer. You're a controls engineer or an electrical engineer who knows about controllers and actuators. You need to learn the next layer, which is basically the let's talk in terms of core engineering. You are an electrical engineer, you know everything about electronics and electrical and stuff. Now all you need to do is understand the next layer, which is mechanical, motors and actuators. And if you're mechanical, you understand a little bit of industrial engineering, like simulation, digital twins and stuff. And if you once you get like 2 to 3 layers already done, I think it's also good to start learning about the decision layer, understanding the software. So getting familiarized with it is much better than jumping inside and being an half-baked software engineer at this point, because they've already gone too far than where we are. So the best thing is to understand, and then finally, whoever gets all five layers, like whoever gets to the purpose layer, who's basically understanding every single part of the system, will be basically a product manager or a TPM or basically CTO of physical AI companies. And then because they understand the entire system at this point, so they will be
Mm.
able to coordinate and collaborate and make sure that the product arrives finally, or product or purpose arrives, to be honest.
Okay, great. I think then let me ask this question, which is, I'll take my example. I used to do a lot of digital twin modeling. I used to do 1D physics based simulations. I used to build the engine, right? The power from the engine to the wheels, and look at the whole system and fuel economy and drive cycle simulation, etc. Now, I'm assuming that I was already close to the simulation layer. I had some experience of the mechanical layer. What I could learn from next is maybe the decision layer. Yes, there is this actuator layer and perception layer there,
Yep.
but maybe if I have to go through my interests, then I go to decision layer? Because I already had some experience of developing neural networks and stuff like that. So I'm guessing that the neural network experience I had matches very well with the decision layer. Is that how you would ask somebody to review how they should go next?
Correct. You need to understand and learn, but not completely ditch what you're doing and then jump into, oh, that's a new layer. That's kind of like making the money. Let me jump into that. You don't have to do that anymore. Or at least like within the next 5 years, we will see everybody, all the 5 layers, people rising up. And whoever understands 2 to 3 layers or 4 to 5 layers will be like really like they'll be in demand, to be honest. And
Hmm.
um, so yeah, like you said, if you already have digital twin experience, you already are a mechanical engineer, and then now you've done neural networks, then you already have 3 layers, Varun. So
Hmm.
you just need to learn the remaining 2 layers and understand how it works together as a product, and then you're all set.
Okay. I want to ask you about how to learn about more about these layers and kind of get very deep familiarity because you mentioned courses. Before that, a slight question just for my understanding. When you talk about these different layers, are you talking about that as are you talking about that as a process, like you go from this layer, this layer, this layer? Or are you talking about a hierarchy that once we solve this, we go to this? Once we solve this, then the next version of physical AI is going to be this. I'm guessing it's the prior, right? It's more like a process to get to the physical AI destination.
Yeah. So, in terms of how physical AI will take place, there is some more time. Right now, like 2 days back, I was in a robotics or supply chain conference or trade show, and I attended one of the sessions which spoke about the same thing. Are we already in physical AI? Is it real or an hype? So,
Hmm.
like very good session about that. And to be honest, it will take some time, Varun. It's not going to happen
Hmm.
right now. Even if you see, I I believe the biggest physical AI product out there, I think, is Waymo's and Tesla's, because they
Hmm.
make decisions on their own. But the biggest phase of physical AI will be humanoids, which is
Hmm.
coming. Like Figure AI and Tesla and a lot of other companies are doing it, but all in a controlled environment at this point, because we're still learning about that. And so it will take around like 2 to 3 years, 2028 to 2030 is going to be there. So that itself is coming in phases, right? Right now, we are still in agentic AI, and people are still arguing if agentic AI is real or not. And even though, like, I see every day I read about agentic AI, like, people are still not, agents are not used as much as generative AI is used. No one's building agents the way people are just using ChatGPT like Google Chrome, like 5 years.
Hmm.
So it's coming
Hmm.
in phases. So there is no rush. All I wanted to say is, and even I'm learning through the process, is that you are not getting left out. No one is getting left out of the physical AI race in 2026. But if
Hmm.
you are not even aware of what's coming, then physical AI is the only chance where a lot other engineering fields can get into the picture. And if you don't start learning through the process, then you might miss out a little bit. Now, to answer the first part of your question, learning physical AI is kind of like a process. You don't jump directly into the purpose layer when you do not understand the remaining 4 layers. So I would say look left and right. If you're already in one of the layers, definitely every engineer is in one of the layers at this point. Look to the next closest layer, which is, for example, as a mechanical engineer, you know about motors and actuators. The next closest is understanding perception, which is cameras, sensors, and lidars, and then going back and understanding digital twins, kind of like go up and down, and then start learning about software a little bit.
Nice. Um, This reminds me of a game. I'm a big gamer. I've had PS1, PS2, PS4.
Wow.
In PS4, there's a game called Detroit. If there's any gamer out there and they want to know about humanoids and physical AI, play that game, and it is coincidental, right? My whole life I've been in the Detroit area. The game is called Detroit, and it is fantastic because it talks about how humanoids will interact with people, and it almost looks like it's going to be a reality, which is scary. So again, any if there are any gamers out there, I think they'll appreciate gamers plus core engineers. I think they'll appreciate this a lot. Which are the courses, Joshua, that you learned from that you think are very effective for people to get an understanding of this whole world?
Definitely. Courses have been, there is no course called Introduction to Physical AI at this point. But again, we go by.
Sounds like an opportunity, Joshua.
Oh, yeah, maybe. The more I learn, probably can, do something about it. But yeah, in terms of learning and understanding physical AI, we go layer by layer. I think the most fundamental course, not even physical AI, I think every AI engineer in this world has taken and is taking is by Professor. But I don't think it's professor. It's Andrew Ng. He's very famous. Yes. I keep following him on LinkedIn, and he has a course on Coursera called AI for Everyone. Even software engineers and data engineers and AI engineers take it. It's for non-software people. To be honest, it's not even written, or he didn't even teach that for software people. He's taught in such a easier way to for lay people, like non-software people like me, to understand. And it's called
That's
AI for Everyone. I think the title makes much sense. So definitely everyone should take that course. It's on Coursera. Do that course, and then I think the second big. There are many courses. I think I can give five, but I think to start with, the second one would definitely be Introduction to Robotics. It is by Professor Katib from Stanford University. It is very famous. It's legendary at this point. So just anyone should just go type Introduction to Robotics, Stanford, and then AI for Everyone, Andrew, and then they'll just get these two courses. These two courses are enough for someone to start. And
excellent.
yeah,
Give me the other three. I mean, that could be a stretch goal, right? This
yeah.
is the introduction, and the stretch goal is the other three. What are the other three?
So the third one is also by Andrew. I think it's called Deep Learning Specialization. It's also on Coursera. And yeah, just type Deep Learning by Andrew Coursera, and then you'll get that. That's a wonderful course to understand neural networks, reinforcement learning, machine learning. I knew only these terms long back. I didn't know what these are until I took the course. So it's really good for anyone to go and take that course. And then the fourth course I would definitely suggest is under actuated robotics. I think it's MIT. I found it on EDX, I guess. It's by Russ Tedrick. So definitely that's a really good course. It's a complementary course to Introduction to Robotics. So Introduction to Robotics and under actuated robotics are really covers everything what robotics is moving towards. And then I think the fifth one, I would give this like a resource where people can just go and choose what they want, because uh, I did some courses, but then I found this by NVIDIA. It's called the NVIDIA Deep Learning Institute, I guess, and there are multiple courses in that. Especially robotics with Isaac, I think is there are multiple courses. It's a track, I guess. There are multiple
Mm.
courses in that to understand like what everybody wants to do. NVIDIA is really like creating a lot of courses for people to understand what's really happening. I think Jensen is kind of like the father of physical AI. Like he's getting that thing. So they're doing a lot of wonderful courses online. So definitely check out NVIDIA Learning Institute.
Wow, that is awesome, man. When you were listing them off, I was thinking about how my energy and creative juices have kind of gone from engineering to entrepreneurship. But when you were saying all of these things, it almost felt like, oh, wow, okay, there's something interesting coming back into engineering, right? I mean, I think that is great. I have a really good question, which aligns very well with the topic that we are discussing. By the way, if anybody has questions, please put it in LinkedIn or YouTube comment section. It will show up for me in the Restream studio here, and I'll bring them up as and when they are appropriate. This question is, how do you balance learning across the system? I'm guessing across the different layers versus getting really strong in one area early on.
Thought provoking question, to be honest. So I would say it's very tough for someone to get across a system in a very short period of time. Even I'm not there. I think it will take some more months or probably years to understand every single thing, because every single layer is, is someone's career. Like, one person is doing mechanical engineering throughout his life and he's developing that. Similarly for software and stuff, so it's very tough to understand everything at once. But yeah, people are gonna do it. Like, we're gonna see people who understand the entire system and become the winners of physical AI. But how do you balance? It's, I would say, at this point when you're starting, do not try to balance it. Learn step by step, learn where you are, get deep into that, go to the next one, and then it will take time. It's but also remember, you need to become very strong in one, and then you jump into the four, and surface level fine, but also go a little deeper into that. But one layer of that should be your basic, like an undergraduate degree kind of thing, and then the remaining can be like a master's, like a course and course and course kind of thing. So it's do not start like, or please do not take both, all the five courses at the same time and start understanding all five like constantly in five tabs or something. Go step by step. I think anyone who's in a core engineering background can start with robotics and then go to software. Similarly, if someone's already in software, and I think also this maybe not just for core engineers, even software engineers
Sure.
can. So software engineers can start with Andrew's course and then jump into Professor Khatib's course.
Josh, how are you practicing what you learn? I mean, at your day job, there will be a role that you are assigned. And this is true for everybody, either core engineers, software engineers. They have a role that they are assigned, which probably limits their actual output to one of the five layers. If they are learning about a different layer, how do they practice? And in a way that I'm asking you, which is how are you practicing the multiple layers?
Yeah, definitely. I mean, like, everybody is, including me, we're like limited to one for sure. Like, in my day job, I'm a manufacturing engineer, but I do mobile robotics. So I'm lucky enough to be in the same one of the two, I could say, two layers, in between two layers, in between uh, digital twins and software. And it's a very niche role, so I'm really lucky about that. But anyone else will definitely be just in one layer. Take for example a mechanical engineer, he's doing CAD design, right? Or like some kind of 3D design, 3D modeling. So what he that person can do is start, I think first thing is start talking. Like, who are you designing for and what are you designing for? Like, if you're designing for something which goes inside a car, then you will also start talking to the electrical engineer who's also designing an electrical architecture for the car. So first start talking and start understanding what they are doing and what you are doing. I think in corporate, like, whatever you do, sometimes, like, we think that, oh, this is kind of like one of the smallest part of the entire picture. But that's not the, it is true, it is true. Like, all everyone's work combines together and then it forms a product. But what you can do is, you're contributing to that one thing. You can talk to the next person. It could be a different team, could be a different engineer whom you've never met, but still you can understand, talk to him or her about what their role is. And then you start learning through that process. You understand what they are doing. Maybe it's an electrical or a software engineer, and then what you are doing, and then you first observe and talk and understand, and then take all these courses, and then get to that. So coming to my role, and even I'm limited into it, but I also talk a lot to software engineers in my team, in my broader team. I talk to the electrical and controls engineers to understand it, even though it's not kind of like my job. but I still try to understand what they're doing. And then, I don't have to do their job, but I can still understand their job. And then they ask me questions, I talk about my expertise, and that's how we learn each other. And soon enough, we physical AI is going to give you a lot of opportunities to cross functionally work. And then even if it's not at a day job, there's a lot of online things which you can start doing. Like I said, Nvidia is getting up in the game. They have omniverse at this point where you can learn and understand and also play with their models, and digitally on your laptop. You can at free of cost, I don't know how they're doing it, and free of cost you can start using omniverse. There are multiple things you can actually do. So I'm actually going to start doing some small projects with that. But that's how you understand what the other person's doing, and then you start doing small projects, ask questions. And we all have chat gpt at this point. You can ask anything regarding another field and it will give you like everything about it.
Can you share a bit more about the project that you're thinking of doing with Omniverse and the why behind it? I think people will get a lot of insight from that.
Yeah, for sure. So I'm also doing a little bit of research about certain things related to my role
Mm.
and how I can improve. So basically, I'm trying to come up with a new solution about how humans and robots can interact and do what's currently happening. Okay, so not telling the exact same thing, but I'm just gonna give you an example for it.
Maybe you can use an analogy or an example
Yeah,
from a different field. So, yeah, feel free to not share what you can't share.
yeah. But so at this point, imagine a system where the system is saying, giving certain commands to robots and certain commands for to humans, like tasks, considered a task. So a system is giving a certain number of tasks to humans to constantly keep doing it, and a certain number of tasks to robots to constantly keep doing it. What I am trying to come up with is the system just throws the task
Mm.
and it's out in the open. Now my what I'm proposing, and it's a framework, and I'm probably going to play around with it with omniverse and stuff, is that whether robots are taking it or humans are taking it, and what is the interaction between them, when is the breaking point when humans are saying, no, I'm tired, you take it, and
Mm.
when the time when humans are saying, don't take it, I'm going to take it. So it's kind of like a human robot interaction. That's kind of like my that's what I usually focus on. Like ever since I finished masters, I've been focusing on human robot interaction. It's a niche field, but it's also a very slow field at this point. But I think it makes a lot of sense in the future because humanoids are going to come,
Mm.
and just like we both are talking, a humanoid can walk behind me and I'm going to interact with me. So there's a lot of research in terms of how humans will interact with robots. Right now it's just like six axis robots and stuff where humans are close enough, but eventually robots are also going to talk, or like do actions like humans. So that's kind of like my focus apart from everything else I do. So yeah, that's kind of like the the thing which I'm thinking about and trying and testing it out, honestly.
And how does the Omniverse framework or the system help you test these things or help you learn or try these things?
Yeah, so with Omniverse, you will be able to simulate whatever you feel like, and they have like robots, and it's the compute is it's amazing. You'll be able to simulate the same scenarios you want to. It could be anything. It could be like I don't know, maybe two robots fighting. I think you can still simulate that in Omniverse, and you'll be able to test it out. Just like when I look at some videos of how people are using Omniverse, I think I've only seen such stuff in movies until this point.
Mm.
Like just doing like crazy stuff with. I think early Unity was doing it. Now Omniverse is really up the game.
Is it all prompt based or does somebody need like a learning curve to be able to use this tool?
Yeah, there is a little bit of learning curve. Even I'm learning at this point. So, like I said, NVIDIA Foundation, the website, the robots with Isaac, they have like guided learning courses on how to learn and use these ones. So it's really
Okay. Very interesting. I think we are on the topic of application and how to kind of build your skill that way. This is a slight digression while being in the similar topic, which is in your experience, right? When you're deploying systems like that, like AMRs, how much do tools like digital simulation or digital twins actually hold up once you are in production, especially around workflow
yeah.
and material flow?
Yeah, great question and really valid question, because digital twin per se can only help you get from your thought to reality. It's kind of like in between that. It can get you to a point where you can, like, it's not just in on paper. It can give you some kind of information. It is definitely not bad, I would say. But if we talk in terms of percentages, I believe like there is 70 to 80 percentage you can come up with, okay, yeah, the simulation or the digital twin is saying that. It is not 100%. Reality is definitely different. Of course, I wouldn't say different, but it is different than what the results you get on a digital twin. uh, and I think that is why it is also one of the layers, right? The fifth layer is a purpose layer where product managers and actual good TPMs are going to come, is that because they know that 30% gap, and then they will make sure that 30% gap is fixed in execution.
Hmm.
They'll make sure that they'll find out the gaps early on with all the four different layers, and on the fifth layer when they execute it, they'll be able to like understand. They can predict it, they cannot predict the solutions, but when the issue happens, they know at least the root cause of it. They'll be able to say, oh, this is because of the perception layer. They'll be able to say that at that point. So I would say 70% you can, it lives up in production, but the remaining 30% is dynamic. You will never know, and you can just come up with last minute.
I will actually piggyback on that from my experience as well, having worked in a digital twin. To give you a specific example, one of the projects I did was to convert a conventional vehicle into a mild hybrid vehicle. And we first started with simulation, determining motor size, battery size, control strategy, etc. And we were able to showcase a X percentage value of fuel economy benefit.
Oh,
And I think 70% of that translated to the demonstration vehicle. 80% I think would say would translate. Obviously you still need to tweak, you still need to tweak the control strategy, you still need to kind of change a lot of parameters. One interesting thing I'll add to what you were saying is there will be some floaters who will be in different layers. So floaters who took part in the digital twin, then took part in the calibration and stuff like that, and then took part in seeing the demonstration vehicle actually come into production. So I think the floaters will be the key part of the forward deployed engineers, like the product managers, TPM, and stuff like that. I think that is a great position to be in if you want to kind of play multiple hats.
totally, totally. Yeah, I think that will definitely shape. Like right now, we are software product managers, which is kind of like the majority, and then a little bit of hardware product managers. But with physical AI, we'll see like true product managers who understand the entire product end to end. Right, that'll be like amazing.
By the way, anybody who's joining us live, if you have questions, feel free to put them down. I will ask them the same way that I have asked these questions so far. I think I want to change gears a little bit at this point, Josh.
Yeah.
How much of what you have been able to do with physical AI, even learning about it or implementing it, how much of that is a function of being in a company like Tesla?
Wow. So I am still in a very conventional role, like a core engineering role. I am not an AI engineer So Tesla is huge at this point. Like there are so many verticals. Like I don't even know what's happening on the humanoids front, or like energy front and stuff like that. I'm in the vehicle space. I'm a manufacturing engineer, so but since I'm doing mobile robotics, which is kind of like, it's kind of like autonomous. It is autonomous, to be honest. So I get exposure to the same concept, but I it's not on the day-to-day job that I keep expanding my knowledge and things about physical AI. But I did see an opportunity to, understand. Oh, I think the biggest learning, Varun, is that I realized that my job is part of physical AI, that what I'm doing is part of physical AI. And I think that is true for a lot. I think 99% of the engineers. It's just that they do not understand that they're already a part of it. I think the biggest message I want to give from, talking today is that I want everyone to just understand that they're already a part of it. They do not need to go out and learn something new. Of course, they need to learn, but not something new, which is away from their 9 to 5 job, something totally computer science related, to understand and to be a part of physical AI. So I think that is the biggest revelation, I understanding I got a year and a half back. And yeah, again, to answer your question, day-to-day job, I am seeking opportunities about how to connect to the other layers and then learn about it so that I grow myself, in this space. So my role, I'm happy to, I get these opportunities. Maybe a different role in my previous role, when I was a process engineer, I did not have exposure to a software team, but I had exposure to a data team. So I learned a little bit of data engineering, right? Not like in a way to create my own data sets and stuff, but I understand what they are doing, and kind of like a middleman about, taking my requirements and understanding. Sometimes they come back and say, oh no, this cannot be done, and I understand why they're saying that. That kind of an exposure is what I did. So every job, there is some kind of an opportunity to understand another field and, get more exposure, and to be kind of like the person who understands the system. That's kind of like the most important part, and I think everybody has that chance. Like even the software and the data engineers at Tesla and most of the companies, they work with a lot of, non-software engineers, and they understand how the system works actually.
Absolutely. I know a friend of mine who has been a transmission calibrator all his life. He's starting to learn a lot of data analytics because he mentioned how traditional data scientists, data analytics folks were not able to understand the requirement of the transmission side. So I think there is a literacy gap that will be filling from both the sides as this continues. What I found encouraging in what you said is two things essentially. One is that everybody is already part of it. Like 99% of the people are already part of it. I think once you learn physical AI, at least you will have a grasp of the terminology or of the landscape of things where it can bring in communication, it can bring in positioning difference to what you are doing. But it sounds like your day-to-day work is already there, which is great. And the other thing you mentioned from, or what I got from this is, you don't need to be in the best future focused company to learn and execute on this. So I think that is encouraging as well when you say that, okay, most of my role is still core engineering. Obviously, I'm looking for how to add more skill set, which is great because let's say somebody is working in an aeronautical company or somebody's working in an electrical company, they can still say that, okay, I don't need to be just in Tesla to kind of
Yeah.
take part in all of this.
Yeah, totally. Yeah, everybody, every company, and every job function has an opportunity to, learn from, cross functionally, and, be a part of it. And then also, like, internet has so much to learn and do and stuff. So you can always like jump from one layer to another, also use all this information and knowledge you're getting to go from a small company to companies like Tesla and Amazon and Google's doing I think Google's doing much a lot of stuff for the physical AI, uh, the race actually. They're doing a lot, even in robotics. So I recently got to know Google's doing a lot of robotics recently. So there's a lot more, and startups. There are amazing startups at this point. Like there are there are startups which I think will become like the next Tesla at this point. There are some startups which are doing amazing work, which I think Tesla and Google are also doing similar stuff. But look at it, a small 50 people group is also doing something which a big giant like Walmart and Google are doing. So it's everywhere.
Very cool. I definitely want to get to that piece. What I think there is another opportunity here is for people to stay in their organization, but become the leader of that organization in this space. Be it communication, be it future product development, be it, educating the people around them. Outside of the courses that you mentioned, what are some things that you think they should learn to be the leader of their organization in this space and even kind of promote future products?
That's a question which I'm also learning through, because it's also a new area, right? Like physical AI. No one, at least around me, is talking about physical AI. So, but there are traces of physical AI. So I think one thing, in more than being projecting as a leader, we can ask the right questions at this point. Even though I'm learning and most people are going to start to learn, what even though your company or any company is not basically having, I think only Nvidia has like physical AI engineers at this point. I attended a session like a month back where Amit Goel from Nvidia spoke about physical AI. He gave a long lecture about physical AI, which means Nvidia has a division called physical AI, and if you go to their website, they have a lot stuff related to physical AI itself. But not every company has this particular term and this division. But eventually, they all will, because that's needed. But what we can do is we can take some of these layers and you know ask the right questions, because without even knowing that all these different layers, maybe not every product needs all the layers, but there are at least 2 to 3 layers which every product currently in 2026 has. So even if you understand 2 to 3 layers and then you start asking the right questions, even to the other layer, even if you're not into that, you know, team or job function, but still you can ask the right questions, and then you
Mm,
give them the right exposure to what they are doing in through your job. Like if you're a mechanical engineer, you can give the electrical or uh, the industrial engineer what he needs to make his part of the product successful. So, and that comes only while you understand multiple things. You cannot, like, I think if anyone is gonna be like, oh, this is my job, that is not my job, I'm not gonna learn that, I don't need to that. Of course, no one's paying you to learn that or even talk about that. But anyone who's gonna have that kind of an attitude is gonna be left out. Anyone who's like,
interesting.
I don't care, I'm gonna learn everything, is the person who's gonna, eventually have those kind of attributes in them, and then they're gonna like be at the right time, they'll just they'll get visibility on them. And probably they, yeah, like to answer your question, they'll become the leader of that.
You know what this reminds me of what you say is there was a time in the auto industry, at least, where the whole thing was whole advanced engineering budgets were moving from internal combustion engines to electrical vehicle engineering, right? I mean, surprisingly, it's actually starting to come back, which is a whole another story for a whole another podcast. My point being that when that was happening, I had already put in 10, 11 years of my career in internal combustion engines
Mhm.
and advanced research of that. what I had to come to the realization that, look, I'm an automotive engineer first, then an engines researcher. And if I have the automotive engineering experience, I can always learn electric vehicle technology. It's not like it's not like I'm forgetting the fundamentals. So it almost sounds like as long as you can go back to the fundamentals, you can learn this new advent of robotics and physical AI as well. What I will say to add, right, is once you start learning, especially early career folk can do a lot of lunch and learns, right? They can share what they are learning internally in the organization. They can definitely have conversations. I love that you kind of double down on that and asking people to have conversations. And then people who have much more experience, I have 14 years of experience, so I know that I can go through the same training and see different vantage points, and maybe that can I can add to my team and said, okay, this is what I learned, this is where our products, this is how our products can look like in the future. So I think there is a lot to be gained out of this from just starting out to
Yeah.
kind of learn about this process.
Yeah, yeah. I think everybody should just start talking and
Mm,
sharing. Like, yeah, everybody is an expert in something or the other, and just like understanding, asking the right questions, and getting the right answers from the right person, and then thinking about it, and then understanding what they're saying. I think if that starts, that is a really good space to be at. And if someone's in a space where that is not happening, where you're not able to talk to the next, like, another person and understand, get his mindset, or like get their expertise, then you should definitely change the space. Like, that's not the right place to be. In
yeah.
early career, like, it's very important to get that vibe and learn more. And then maybe some people also change careers after like so many years, and they're like, oh, I like this a lot, and that could have all started just with asking one small question, right? So
Excellent point. It's almost like if you can see from the port or the dock the story of Titanic. Like if you knew the story of Titanic from the dock, you will not step on the Titanic, I
yeah,
think. So I think that is interesting that this conversations and this learning can also help you see if your organization is going to be somebody gets who
yeah,
takes part in the disruption or gets
yeah,
disrupted in the process.
totally, yeah.
About that learning, I have another question here, which is on the point of TPMs identifying where systems break down. So they've learned all the 5 layers, have some kind of understanding. As an industrial engineering student trying to learn through internships, what can I do to start now?
As a student,
Somebody who's learning through internships. I know it's a little bit early in the journey, but I'm glad that they are thinking
yeah,
about
yeah, as
thinking.
an as an intern, as a student, as an intern, definitely, if you're thinking about where systems break, that is a question which many people do not ask. So good one on that. I think through internships, I would definitely, I'll probably switch back to a career mentor kind of mode at
Yeah.
this point. So I think it is, if you already did one internship in a particular role. For example, you're an industrial engineering student, so you already worked in a company as an industrial engineer. Now that you want to become a TPM, and change, understand the entire system, you would easily get another industrial engineering internship as a student. But I would say put more effort to get an internship which is different from being an industrial engineer. So if you're an industrial engineer, next internship you will definitely get an industrial engineering internship, but try a little bit more to get an internship which is not industrial engineering. Could be systems engineering, could be mechanical engineering, or could be electrical or something. Of course, you will not. They might ask the questions, "Why do you want to do that?" You can say, "Hey, I'm a student. I want to learn certain stuff, and so that's why I want to get this internship." But even before applying, you also need to do some prep work, right? Like you, when you want to become a mechanical engineering intern, you definitely need to know a little bit of 2D and 3D modeling, basic strength of materials and stuff. So prep that. I know it's a lot to do just after getting a job, but if you do that preparation right now and then go get an internship, and then the internship is not, you're going to learn every day. That's the beauty about changing, roles. And that not a lot of people do that. To get a job, it's very easy to just build on, stack on the experience. But only when you change roles a little bit, that's when every day is like a learning curve. You'll understand, you'll get different perspectives. Like when I started as a TPM at Tesla, and then I became a process engineer. So I was a TPM in an automation team. Then I became a process engineer, which is hardcore industrial engineering. And then I again came back to mobile robotics. So it's kind of like shifting places, which is something which early careers and students should definitely do.
Excellent. I think that's a great point of trying to find opportunities in related fields, yet different from what your last opportunity is. And in fact, in the interview setting, you can talk about physical AI and
Yeah.
how there are 5 layers, and you want to have like a rounded off experience where you can touch upon all those layers. So in fact, that will be my advice to you, is that
Exactly.
use that. Specificity always helps in such a case.
Yeah.
This is a great segue into the final question I want to ask, or the final area that I wanted to touch upon today, which is, how does somebody prep themselves to be at a place where a lot of this work is happening? So I'll give you an example. Let's say this is a core engineer working in a company called like GE, for example. Still a big company, awesome place to work for, makes appliances and stuff like that. Maybe they might already have a really good physical AI division, but just for the sake of argument, assume they don't have that. And now you are looking at NVIDIA and Tesla, at Google, and all of these places. How does that person, let's say they are mid career, I mean, how 5 6 years of experience, I know I'm putting a lot of assumptions, right? It almost sounds like that engineering exam that we have where not a lot of things are given and you are saying, okay, starting with these assumptions. But I'm trying to make sure, how can somebody who's still at a really good company use that as an advantage, use learning as an advantage to get into the leading companies of this space?
So to get into the leading companies who are doing physical AI, I have spoken to a lot of people. Since there again, that is the reason of this talk, right? Like at this point in 2026, no one, or like very few people are, you know are able to understand more than two layers at this point, right? So your competition is equal, like everybody is at the same boat. And also the companies know that. I was talking to a person, and then that person is a director who's doing physical AI, and that's what he said to me. He said, Josh, everybody is new to this, including him and all this team and stuff. They're like, everybody's new to this, Josh. So there's no one where we can say, oh, this person is a physical AI giant, pick him and hire him. We're just taking people who are good at one layer, but who have an attitude and an aptitude to understand and learn other layers. So that is why I started with the fact that start learning right now, because right now the companies are looking for a person who's good in one layer, and who have the aptitude to learn other layers. But right now, if you just start learning and then you go with one strong layer, and then you already know one more layer or two more layers, you're already at an advantage at this point, right? Like the entire system needs to work, so the more layers the better. So if that person is in, already with 10 years of experience or something, definitely he, all they need to do is an inspection. They already, I think they would know 2 to 3 layers at this point. They just need to like bring out the list it down saying, hey, I know 3 layers. They just need to, sometimes they don't even have to learn it, or like study new things. Like I read a post from a lawyer who was writing about EB1 visas and stuff. He was like, there are a lot of people in America who are already eligible. Like they don't even have to like do something more. All they need to like take out and say, oh, I already have all these under my belt. So that's kind of like the one thing, which is not my advice, by the way. I got it from a director of physical AI in a very big company at this point. And he said everybody is in the same boat. Nobody is like having 3 4 layers. So if anybody has the aptitude, we'll just look at that one layer they're very strong with and then hire them. So that's why I'm telling the students and everyone to start learning now. That's the best thing you can do at this point. And then within a few years, it's not going to happen in months. You cannot achieve physical AI, good knowledge in months. Maybe like in 3 4 years, you'll definitely have like at least 3 layers or 4 layers, and that is massive. That will be massive.
Awesome. That is great advice from that director. You know what came to mind when I was hearing you say is that if I was in my engineering days, even at like 14 years of experience, what I would do at this point is I would learn anything and everything that is to learn about this space and just dedicate myself to write one post on it every day, just from a beginner, just
Yeah.
from a beginner perspective. Like, okay, today I went to this course, this is what I learned. Just from a beginner perspective, just start documenting. I know, I think in 6 months, I will be able to know at least who the best people are in this space. And they might know me by having read one of my posts, even if it is from a beginner angle. That is exactly what I would do at this point. If anybody's here listening and if they think that's the right advice for them, then that is something to implement as well.
Yeah, no, that is the best advice. Like learn and share and do it, make learning a process. Like it's totally fine that people know that, oh, that guy is still learning. Physically, it's okay. At least I'm
Yeah.
learning. That's the biggest thing. Right now, no one's even learning. At least I'm learning. So learn, I would, even I'm going to write a little more about physical AI. I've been writing a lot about mobile robotics, but I'm going to start about physical AI. But yeah, everybody is gonna like learn, and there's 5 layers at this point, so it's not like someone knows all 5 layers. So it will take some time for everyone to even learn like 3 4 layers, and
Yeah.
just like through that journey, talk through that journey at work. Like, yeah, if maybe your colleagues do not know about physical AI, you can start talking about them, and then they'll be like, oh yeah, I'm also doing a layer already, and then they can start talking about it, and that's how this entire process. And you're not losing by just telling what you're doing to others. Like everybody is just going to grow and you're going to be successful.
You know what I loved about this episode, Josh, is the underlying theme that there's not a lot of FOMO here. Like a lot of AI stuff is very FOMO inducing, where you feel like, oh shit, you've already missed out. Whereas
Yeah.
what you've done through this entire episode, I think, to whoever was listening live and will listen to this recording, I think they will benefit from, and I benefited from, is that there is room to learn, there is room to grow, and you might already have skills that you can take into this entire landscape. So I think you've done a great job at that, at helping all of us understand that people already have some of the layers and what to do next. So that is excellent. Already got a really good kind of takeaway or a conclusion from this person. Thank you so much for hosting this event. Learned a lot about the 5 layers of physical AI. Love the advice on staying curious. So I think you've done that extremely well, Josh. What I'm going to do at this point is switch gears to the final section that I always have, which is like a rapid fire round. Before I do that, if anybody has any questions for you, what is the best way for them to reach out?
To me, reach out to me.
Yeah.
Oh,
Yeah.
LinkedIn. I'm very active on LinkedIn, and I respond to every single message. There'll be a delay, like some days, but definitely will respond to every single message. Happy to connect. Definitely happy to do talk about your journeys and careers, and That's what I've been doing for a long time, even before I started learning and getting into the physical AI space on LinkedIn. And my life, I've been like very passionate about giving back to the community. Uh, I've been sharing jobs and motivation for a very long time, and I will still continue to do that. But yeah, definitely let's connect on LinkedIn, and yeah, maybe someday we'll all meet, like, or maybe meet in the physical AI world.
You know what? One thing we've not touched upon that we talked about when we first met was your UPSC
Yeah,
journey and how you tried that out. And I think that is something that we'll touch upon in the next episode whenever we have that. But I think it's great what you have done on LinkedIn. That's how I came to know about you. That's how we became friendly on the platform. I love that you respond to all the DMs. By the way, do you respond to DMs which like, okay, I'm so and so, find a job for me? I get so many of those and I'm so irritated by them.
yeah, that happens, but still, I mean, like I've created posts, I've said, like, written posts saying, please do not, you know, and I've also written both ways. I've said, don't do that. And I've also said, please don't write big messages to me like, hey, Josh, how are you? Hope you're doing well. Hope your life is going well, blah, 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 blah. And then they're like, can you review my resume? I'm like, it takes a lot of time to read that. So can you just say, hey, Josh, review my resume? So I do take time. It is a big thing, like more than creating content and posting and stuff. It takes a lot more time and effort to respond to everyone, which I think is more important to me because I've seen the benefit of helping people. A lot of people have benefited by me sharing jobs. They've got jobs, they got internships, so they've switched jobs at the right time. Like, people have texted me saying, hey, Josh, because of I had a database kind of thing where I kept posting the actual recruiters, and people utilized it very well. That I once got a message from a person who said, I just got laid off, but then I used your database, and then within the 60 days, he was on an H1B at that point. Within that 60 days, he got the job, like another job.
Nice.
So
Nice.
I know that people benefit out of it, even though it's a lot of work and it takes a lot of my time too, but I'm really happy to do that. So yeah,
Awesome.
yeah.
I'm glad you do that too. And my internal rule is because I mean at some point you have to create rules for yourself, otherwise you will just spread yourself out too thin. My internal rule has been if you spend less time sending me a message relative to the time you are asking out of me, I'm not giving that time. So for
Mm.
example, it's like, hi, can you review my resume? You are now asking me to spend more time than the time it took for you to just send the message.
Yeah.
In that case, I appreciate the message, but I can't respond. Otherwise, I'll go. I mean, at some point, the volume will outgrow, so you'll have some
Yeah.
rules for that. But that's cool. Switching to the rapid fire round. For me to know you a little bit outside of all the things that we have discussed today and also in the past, I would love to ask you some questions like that. Ready?
Yes.
Oh, okay.
Let's do it.
All right. First question. What is. Wait, I'm blanking out a little bit because I always have like a set flow, right? So I think, yeah, I think the first question is favorite movie.
Of all time,
Yeah, you can, yeah, of all time, maybe.
I love Vantage Point.
Oh, okay. Interesting.
Yeah.
Remind us who was in that again.
That's a tough question. I
Okay.
don't remember. It was like 10, 15 years back, but I really love that movie.
Okay, I'll have to check it out. Your favorite cuisine when you're going out to eat.
Indian.
Okay, nice. I've heard a lot of that in these episodes, and obviously in mine too. They actually no scratch that. Wood-fired pizzas for me. I think that's my go-to
Okay.
if I'm going out to eat.
So when you
The
come to our
next,
place, I'll take you to a nice place.
I've actually been to Austin. I've been to a lot of amazing Mexican and Italian places with my cousin. One of my favorite spots in Austin is like that coffee shop near the lake. I don't remember the exact name of it. Yeah, so I love that place. It's got
Yeah,
such a nice vibe, and you're just chilling. That is awesome. Bucket list destination.
Paris.
Oh, okay. Any reason why?
Just always like that city, Paris.
You know, one thing cool that they did in the Olympic medals was they actually cut a piece of the Eiffel Tower. And like there is a section of the Eiffel Tower that they cut, and they
Okay,
put a piece of Eiffel Tower in every Olympic medal in the Paris Games. I thought that was so cool.
that's crazy.
Yeah. Last one, which is there will be a certain percentage of people who will watch this entire episode
Yeah.
and who will take a lot from this. If you have to give them a challenge that they can do within 2 hours this weekend, not a whole lot of time, 2 hours, what is something that you would ask them to do?
Finish 20% of Andrew's course. That
Nice.
is 2 hours. Yes, you can do that.
All right, awesome. That is a great, succinct, actionable challenge for everybody. Josh, it was great to have you on. It's like you are wearing a white polo, so I feel like I'm looking like a duplicate who has much better hair than I do. But it's been awesome to have this conversation. Thank you so much for your time, and I will talk to you soon.
Definitely, Varun. Thank you so much for hosting me. The pleasure was mine. It's really, refreshing to me on why I started this, and then I'm happy that I'm able to give back. But thank you so much for having me on the show, Varun.
It was my pleasure. Thank you for everybody who joined us live, asked really good questions, and whoever watches.